Welcome back, Math 2. Today we're going to look at the relationship between the scale factor of sides and perimeters to areas. Okay, so let's just jump in and let's see if we can find the connection. Okay, so number 1 here says to find the area of the two different rectangles below. So first off, looking at the two rectangles, they are similar because if I take 2 times 2, I get 4. And if I take 5 times 2 as well, I get 10. Okay, so we know that they are similar. And that means I can actually answer part B here. How many times bigger is the second one than the first one based on the sides? Is 2 times bigger. Excuse me. Well, let's go ahead and actually answer that question of the area and see if there's something different. So remember the area of a rectangle, I'm just going to take the length times the width. So 2 times 5 gives me an area of 10. 4 times 10 gives me an area of 40. So that means my second one, to go from 10 to 40, to go from 5 to 10, we times by 2. But to go from 10 to 40, I have to times by 4. So based on the areas, they are 4 times bigger. Okay. So that means that the ratio of my sides, or the similarity ratio, is going to be 2 because it's 2 times bigger, but the ratio of my area is 4 times bigger. So I want you to keep that in your brain. What could the connection be between 2 and 4? Why is it different? Okay, let's try it again. See if it helps to get another connection. Okay, same thing, but now we have triangles. Quick refresher, the area of a triangle is 1/2 of the base times the height. So based on our sides, to go from 3 to 9 or 5 to 15, the second one is 3 times bigger. That would be my side ratio. But my area, let's see, 1/2 of 3 times 5. 3 times 5 is 15. Half of that is 7.5. And this one, 9 times 15, is 135. And if I multiply that by 1/2, I get 67.5. I doubt that it's times 3, so I'm going to do 67.5 divided by 7.5 to figure out what that ratio is. And I get 9. So the area is 9 times bigger. Okay. So let's look at our two different ratios. Okay. So up here, we had our side was 2 and our area was times 4. And down here, our side was 3 and our area was 9. I want you to maybe try to answer question 3 by yourself for a second. I'm going to give you a minute. So is there a relationship between the similarity ratio, the sides, and the area? What is the relationship? What is the same about going from 2 to 4 and from 3 to 9? Okay. So what I'm hoping you notice, give you a little bit of Dora the Explorer time there, okay? There's a lot of different ways I can get from 2 to 4. And there's a couple different ways I can get from 3 to 9. But the pattern for both of them to work is that to get from 2 to 4, I have to square 2, and I have to square 3 to make it 9. Okay? So the relationship is that the area ratio is equal to whatever the side ratio is squared. Okay. So then in question 4, if the area of some square is 30, what is the area of a square whose sides are 4 times larger? Okay, well, if I want to know what their areas are going to be, I have to take their side, 4, and square it, which is 16. So now I'm going to take 30, my area, times the ratio of 16. And I get 480. Okay. And here's the reason, okay? When you're just doing one side at a time, you're working in one dimension. Okay. Do you ever notice when you have to write labels in units, if you're dealing with area, you have to do the unit squared, like inches squared or square feet is how we refer to it a lot. That's because all of a sudden you're working in two dimensions instead of just one. Okay. We're going to skip that last question. Let's jump all the way to the back here. Okay. I want you to keep this in mind, and we're going to do problems 9 and 10. Okay. So problem 9 says to find the perimeter and area of TUVW, or the smaller circle here. Okay. So let's see here. The ratios we have, we got to start with the sides. Okay. My bigger shape has a side of 21 and a perimeter, it says, of 72. Okay. That should be proportional to having that side of 14, and I don't know what my perimeter is yet of that smaller shape. Okay. So this is all for the perimeter. Okay. I'm going to cross multiply. So 72 times 14 is 1008. I'm going to divide that by 21. So this perimeter should be 48. Okay. But now to get the area, it's a little bit trickier. So I want to figure out what was that ratio, that side ratio, that makes me go from 21 to 14. So I'm just going to write 21 over 14 and simplify that fraction. They're both divisible by 7. If I divide them by 7, I'm going to get 3 over 2. Okay. That is my side ratio. Okay. I'm going to square this, and that will give me my area ratio. So when I square this, if you remember back from Unit 1, this is really just going to distribute to both the 3 and the 2. So 3 squared is 9. 2 squared is 4. Okay. So now I can say, all right, well, if the area of the first shape is 315, I want to know what's the area of the second shape supposed to be if we're equal to a ratio of 9/4. Okay, so I'm going to cross multiply again. And I'm going to get, let's see, 315 times 4 divided by 9 is 140. So that's an area of 140, and I'm sorry, I forgot labels on all of this. Okay.